Hi Siva.
Hello, sir.
So this is your first ML model product design, right? In this
Yes, sir.
solution demo.
Yes, yes.
Okay. So this is for car price prediction. So what are you going to do in this actually? What is this car price prediction?
So basically, I selected this car price prediction by the ML model. So I have designed as a product design demo for this, like how we predict the car price prediction by using ML, and also initially how the car price values are predicted without ML model. Also, we will discuss in this demo.
Okay, go ahead with the demo. This
Yeah,
is
okay,
only
sir.
solution demo, right? After that, you are going to show the technical demo
Yes, sir. Yeah, technical
with
demo
Python
also.
scripts in non-cloud environment, right? Basically.
Ye- Yes, sir. Yes.
Okay.
So, hi everyone. My name is Siva-18-03-2025. So, I have worked for this demo as a product designing and development activity role I have taken, and I developed this car price prediction ML model by using linear regression algorithm. So, where you can see my LinkedIn profile here and my coach profile also for proof of some demos also. So, okay, let us start uh, the agenda today. So today we are going to discuss about introduction to the linear regression algorithm. What is the linear regression algorithm? Then what are the product design and algorithm selection? So why I want to design product design and what is the algorithm selection? Why I choose this regression algorithm? And what are the current business challenges are involved in car price prediction? Also, we are going to discuss. And then product design requirements. What are the product design requirements we want to measure while developing the ML solution? And also there is a one typical user story also we are going to discuss within detailed steps. And later we are going to design and develop the ML model activities for this car price prediction model. We are going to see all these one by one. So these are the steps to implement the ML model overall. So this is the agenda. Now we are going to see what is the introduction to the linear regression algorithm. So here, the introduction about linear regression algorithm. So basically, this linear regression is a supervised learning algorithm, which is used to predict the numerical values. So the supervised learning means like whatever the data we have, the label and the features, all both are included in the supervised learning. So this is used to predict mainly the numerical values of any use case like car price and like house prediction, that kind of things we can use for this linear regression algorithm. Then it will find the relationship between independent variables, where here in my use case, like features are like car age, kilometer driven, the depreciation something, and a dependent variable is selling price by using the mathematical equation. So that is nothing but y is equal to mx plus b, where y is our target variable. So here in my use case, the selling price is the target variable, and mx plus b, and x is the independent futures. So in my use case, I have some independent futures like present price, kilometers driven, fuel type, seller type, and much many. So I have taken that as the independent futures, and m is nothing but coefficient. So it will give the weightage of each future which is involved in our ML use case. And B is the intercept. So this is a baseline. So that will give the linear line. So this baseline price without any other factors, it is involved for this B intercept. So this is about introduction about the linear regression algorithm. And second one, product design. So we are designing the product. So why we are designing the product? So who will get the benefit from this? So in that case, if we can see, what are the target users and business need while designing the product. So basically car buyers. So they will get the benefit and they will take advantage, take a accurate price estimates to make informed purchase decisions while they are buying or selling the cars. And also dealerships also get the benefit. So they will make a competitive pricing strategies to maximize their sales in while selling or buying the cars to the individuals. And the banks and insurance companies also they will get the benefit because they also want to require some fair valuation system for the loan approvals and the insurance policies also. So we are going to taking all these product requirements and while designing the ML model, we are taking all these requirements in mind and we are developing the solution, ML solution. And here we have mentioned some key features of the product while designing the product of the ML model. So user inputs. So here in our use case, what is the brand of the car? What is the model of the car? In which year it is manufactured? Then how much mileage it has given, fuel type, transmission, and location. So these are the some user inputs we are taking as a key features of the product. And instance price prediction. So it will provide an estimated price. So based on the historical data. So because we are obviously we are giving feeding the historical data to the model and it will predict our data. And the trend analysis. It will give the visualized insights also based on the price variations based on the features like brand, model, and location. So this will give the trend analysis of the price prediction as well. And also comparative pricing. So it will give the similar car prices in the market. So we have like it will display some similar car prices in the market by in the comparative pricing. And also API integration. Yeah, because these banks and insurance and dealerships, they want the system to allow banks, dealerships, and third-party platforms to integrate the predictions. So for that, all these things we are taking in mind and while developing this product design of the ML model. So we have taken all the key features of the product and we are developing the ML solution. And algorithm selection. So here I have chosen linear regression for my ML use case because it is a very simple and effective. So because it will work well for the continuous numerical values like car price prediction and any house price prediction also. Then it has an interpretable model, means it will show how the each feature will give the impact of the target price because how the age and kilometer driven will impact the price target variable. So that's why we are calling it as interpretable model and no overfitting risk involved with the proper feature selection. So because we need to take care of the proper feature selection while designing and developing the ML model. So in that case, there are no overfitting risk, minimize, maximize not involved. So linear models will generalize the well for this numerical values of the use case. And the scalability, because we need to handle the real-time price predictions for the sales team and car platforms. So for that, this linear regression can help us to scale the real-time price predictions also. So these are the some advantages of using linear regression. And coming to the current business challenges. So what are the current business challenges or involved in predicting the car price without using ML model? So these are the some business challenges happened. So like first one is inconsistent pricing because car prices may differ across dealers and across locations and different platforms. So they have different prices with the different platforms. So which will lead into the confusion of the buyers and as well as sellers or individuals also. And lack of data-driven insights because the pricing decisions mainly depend on the experience instead of the real market trends because the people who are taking the decision, they have consider only their experience, but instead of the not taking consider of the real market trends. So that will misguide the real prediction of the car price and the high depreciation impact, because many car values will drop their prices at a different rates because of the brand, model, and mileage also. So the like these are the factors will impact the depreciation car value. So this is the one factor, business factor that will impact the car price and the dynamic market conditions. So because in this economic changes, so many rapid economic changes are happening, and fuel prices are also vary day by day, and these new car models affect the resale values. So these dynamic market conditions also will affect the car price prediction model and the limited customer trust. So basically, these buyers find it a very hard way to give the fair prices in the market for the car. So which will lead into the hesitation and get some headache while predicting the car price exactly as per the trend market analysis. So this will give some limited customer trust also involved. So these are the some business challenges are involved without using ML model. Now we are taking all these requirements and current challenges also we have taken in the mind consideration, and we are going to design the product requirements, like how the product need to be look like. So first one is data driven pricing model. So we are going to utilize the historical car sales data like brand, model, year, mileage, anything. So predict the accurate prices of the car. Then real-time price prediction. So we are going to deploy a model that will integrate with dealer platforms with across different areas for instant the price estimation of the car value. And we are also using user-friendly interface because we are developing and designing, and we need to design the interactive user interface for the like customers, buyers, sellers, and financial institutions. So they will take care and they will give the input car details, and they will get the instant valuation of the car values. So they will get some easily process to find the car price values, to predict the car price values. And also the API integration for business, because we are offering the API also for the seamless integration with car dealerships as well as banks and insurance providers with this user-friendly interface system design. And also we are considering the bias and ethical consideration regulatory activities also by ensuring the model is fair across any region, across with all brands. And also we are using the demographics to prevent the biased prediction pricing, because I like want an example. Suppose in one area it is giving the price to the certain value, and also in another area it is giving the same value. That not we need to consider. So for that we are going to do some bias and ethical considerations also to prevent the biased pricing of car values. And while coming to the typical user story, so basically these are the users like car buyers, sellers, and any dealers, then bank loan officers and insurance agents. So as a user story, so what is their point of view? So we are discussing here. As a car buyer or seller or dealer, I want to predict the fair market price of a car based on the key features or attributes like brand, model, year, mileage, and condition, so that I can make an informed decision on buying, selling, or financing the vehicle. So this is the user story. So while designing and developing, so we need to take care of think like the user's perspective. Then we need to design. So these are the solution steps we are implementing, and we are providing the solution to the users. Like a user access the car price prediction platform, like any web or app API we are developing. And also we are going to develop the inputs for the car details like brand, model, year, mileage. These are some features we have taken. Then we are going to design and implement the ML model, so that will process the past data and it will predict the fair market price as per the current market analysis. And also users get a detailed step by breakdown of the price trend analysis similar to the car prices also. And we are going to develop the user take action also, because the people who are in dealership or sellers, they will buy and sell the car, right? So we are applying some loan also for this, whoever want to buy or sell the car to the individuals. So this is a typical user story we need to understand, and we need to uh, we need to take it while considering designing and developing ML model. And coming to the ML model design and activities. So I have planned, these are the design activities of the ML model for our car price prediction model. So in the first step, we have gathering the data preparation. Then we need to take the data pre-processing and cleaning. Then we are going to see some visualizations on the data analysis or data visualization. Then we are going to future engineering and select what are the important features that will give more impact on the target variable like selling price. And also we are going to see the model selection and training, how it is going on. And also we are going to evaluate once the model is ready, we are going to evaluate of that model, linear regression model. And after that, we are going to deploy the model and integrate with different platforms. And also we are going to see how the model monitoring is happening and maintenance also. We are going to discuss all these things like ethics and regulatory compliance. And finally, how it will design the user interface for this ML application, so that will give more preference to the customers by accessing easily. So these are the model design and activities I have prepared. Now we will see one by one. So the first one is data preparation. So data preparation is the process, so that which collecting the data, cleaning the data, and transforming the data. So finally, we are organizing the data in a proper way before using it for any machine learning model, because it will make sure that the data set is a reliable, accurate, and ready for the training the model. So this is all like data preparation. So, but we have some data privacy issues. So for my demo perspective, I have collected the data from the GPT itself. So I created 1,000 entry points of data from the GPT, and I have considering that as a data preparation. I will show the Excel sheet later once I completed this. So first we need to collect the right data sets, which is required to train the car price prediction model. Then we need to gather tech data from different sources to make ensure accuracy and completeness by taking the data from different like APIs, databases from different platforms, and make ensure that data should be clean, relevant, and well structured before using it in a machine learning model. After that, we are going to see the data pre-processing and cleaning activity. So because we need to do some data pre-processing. So because in the practical live data, we don't have a clean data available, because that's why we should do some data pre-processing and cleaning activity on the data itself. So why is data cleaning important? Because obviously we need to predict the better model accuracy of the ML model. So we are cleaning the data, so that will reduce noise and it will improve the prediction of the ML model. And also we should eliminate the errors as well, because we need to fix some missing values or any negative values or any incorrect values are also. So that will make ensure the reliability of the data should be by eliminating the errors. And also we need to consider the consistency. So by making ensure the consistency, we are defining the different formats like kilometers, miles in our use case, that must be unified, all these different formats of the data. And these are the key tasks involved in the data pre-processing, which I have designed. First one is check the missing values of the data which I have created, then handling the missing values properly, then removing the duplicates if we have any duplicate values in the data set, and also it will handle the unrealistic values in the data. Then it will handling the inconsistent and incorrect data also if it is finded. Then it is standardizing the data format finally, and finally it is save the clean CSV file once completed all these tasks one by one. Then this is about the data pre-processing and cleaning technique, and it will save the file in a updated CSV file. So coming to the data visualization. So once we have did the data pre-processing, now we are going to understand the data patterns, how it is looks like, and what are the trends are involved, and what is the relationship between in the data. We are going to analyze with the help of the data visualization activity. So these are the some key tasks involved in the data visualization. So we need to understand basic data understanding of the and exploration also, like how many rows and what is the data we have exactly we need for this predicting the ML price model. And we are going to unique values and counts how many values are there in our data set. And also we are going to see the distribution analysis of the futures by using some histogram plots, so that we can able to analyze the data properly. And also we are going to see the relationship analysis with the help of the scatter plots and box plots. And also we are going to like finding the outlier detections with the help of the box plots for the numeric features. And we'll do this some correlation analysis also for the numeric features by using this heat map functions. And also we are going to see some trend analysis for the yearly price trend also. We are going to see how it is, how the market value prices are went on. So these are the kinds involved in the data visualization. We will get some better analysis and we'll get some idea about the data. So next one, future engineering and selection. So once we did the data visualization, we will get some idea and insights how our data looks like, and we'll make an informed decision based on the data. So here we are creating some new meaningful features that will predict a better way of our ML model. So we are also removing some unnecessary features that are not contributing any correlation to the predicting the car price values. And finally, we are doing some standardization and normalization techniques so that it will make ensure that the model will perform well on the testing data. So these are the some key tasks involved in the future engineering and selection activity. First, we need to identify the relevant features that are available and that are whether that will features or make the impact or not make the impact of the car price value. And we are going to create some new features that will impact our model exactly. And also we are handling the categorical data, and we are converting the categorical data into numerical data before doing the feeding into the training the ML model. And we are going to select the most important features that are mostly mostly predict our exactly accurate value. So we are by analyzing the correlation analysis. And also we are doing some eliminating the redundant or unnecessary features by analyzing the correlation analysis maps. We can able to easily find that unnecessary features. Finally, we are going to save in the final CSV file with this new features of the data. So in this future engineering, we are doing these are the activities, tasks. After that, we are going to do some training and model selection and training. So in this activity, we select the linear regression model for predicting the car price. So here we have selected the linear regression model. So we need to train the model using the past car data. So to learn patterns and relationships. So for that, these are the key tasks involved for data splitting. So we need to do first data splitting of the data. After that, we are going to do training the linear regression model. So for the test data splitting, these are the tasks. Like first, we need to load the pre-processed future selected data, which we have get the updated from the previous step. And we need to load the original data set that containing the target variable, that is the price, car price. And we are going to match the selling price back to the future selected data set. And we need to validate the successful matching. Then after that, we are going to separate the futures as the X and the target variable as a Y set. And we are going to perform train test split. 80% is for the training data and 20% is for testing the data for the linear regression model. After that, we are saving the training and testing sets of the CSV files for the training the linear regression model. So now the key tasks involved in the linear regression model. Once we have splitted the data as a training, 80% of the data and 20% remaining is for testing data. So here in the key tasks involved in linear regression model, we are reading the training features and the target variable on the train data, and we are initializing the linear regression model to train the data and the training data. So we are train the model and the training data. Once we train the model and the training data, we are going to save this model for the future purpose by using this job leap tool. So here we have data splitting activity, and we did the training and the linear regression model. In the evaluation model, so basically the business when come to the evaluation model, so this the business relevance of the model evaluation, because it will helps to the car dealers, buyers, and financial institutions to trust the prediction after evaluation of the model. Then some key evaluation metrics we need to also we need to make it consider while evaluating the model, like mean absolute error. So this will measure how much average price error in dollars or any currency. So for example, if mean absolute error is equal to 2000, then the model price prediction may be off by 2000, up to 2000 will off. And also the R square value. So it indicates that how well the model explains the price variations. So how well the model performs the based on this R square value. So if we take example, the R square value is 0.85. So that means the 85% of the price variance is explained by the model feature. So 85% of the price, car value price, that can be explained by our linear regression model. Then also we'll get some handling model errors like overfitting, underfitting while evaluating the model. So we need to take care of these errors and we need to improve these errors also. So overfitting is nothing but if the model will memorizes the past data prices, but doesn't generalize the on the test data. So that is nothing but overfitting. Underfitting is if the model will fail to capture the real market dynamics on the test data. So that is the underfitting. After that, once we evaluate the model, we are going to deploy the model and we are going to integrate. So for deploying the trained model, it can be used in a real world environment, because we need to make the predictions that need to available to the users via a web API or mobile app or any cloud service. So by making ensure we need to have the scalability, reliability, and the security in the production environments. So these are the some key tasks involved in the model deployment and integration. So we need to set up the deployment environment by ensure installing the Python, scikit-learn, the Flask, and the necessary libraries. After that, we are going to select the model serialization and storage. So whatever we have saved the trained model as a PK1 job for the reuse for this purpose. And we are building the some test API. So here we are using Flask or Fast API to expose the model for the predictions. And we are going to integrate with the applications different by connecting the API with the business models like dealer or management systems. Then we are going to perform the monitoring. It's like logging API request, then tracking the prediction accuracy and schedule the retraining of the model whenever new data comes. If we have any data drift, we need to keep on monitoring and retraining the model. And when come to the model monitoring and maintenance, so because we need to take care of this model monitoring and maintenance continuously, because why monitoring is critical means it's because the car prices will fluctuate based on the market demand and also the fuel prices and the economic factors also. So that's why we need to keep on monitoring and maintain the linear regression model. So because if not updated, the model may be predict the outdated or incorrect prices. So that will lead into the business down. So we need to see the like data drift, like in the market conditions will change rapidly. So that's why we need to keep on updating the training data with the new data. And also we need to do some model performance by regularly checking the mean absolute error and R square also on the coming the new data. And also we need to maintain the model. So for every 3 to 6 months, we need to retrain the model by using a fresh car sales data, whether our model is predicting the accurately or not. We need to maintain the model also. And when come to the ethics and regulatory compliance, so we need to take care of all these regulatory ethics compliance also while developing the any ML model. Like we need to take like bias and fair pricing. So we need to make ensure the model does not favor any specific car value to any brand or region or any category. And also we need to prevent the overpricing or underpricing also. Due to the data imbalance, we may get this kind of errors, but we need to take care of this bias and fair pricing also. And we need to follow the and implement the data privacy and the compliance activities also. By following this GDPR and CCPA, if user data like the car ownership history or seller details is involved, right? So these customer details are is involved. So that's why we need to take the data privacy and compliance activities, make ensure we need to follow this all these guidelines. And also we need to do some continuous monitoring and ethical auditing also while developing the ML model. So because we need to regularly check the model drift and whether it will affect the fair pricing of the car value. And we also need to do some conduct bias audits also to make ensure it will give the fair valuation across different car locations or for the car different types of brands also. We need to do some continuous monitoring and the ethical auditing activity also by following these regulatory compliance guidelines. And the last one, we need to design some user interface for the ML application of our use case. So basically, once we developed the ML model, for like here, because the user will input the data, like they want to predict, then this model will process the input data for the predictions. Then it will generate the predictions based on the processed data, whatever he has given. Then it will display the real-time predictions to the user to understand a better way by following these user-friendly dashboards. So they will they can able to understand easily. And also it will provide the reports and visualization also by easily predicting and analyzing the data. So that will provide to the user in a easy way. So this is the these are the things we have discussed for like ML model design and activities. So in the coming section, we are going to do the technical demo also. as well for this all kind of model design and activities we will see in the next demo.
So this is a solution demo basically as per your design plan, and developed product developed demo will be given under technical demo in the second phase.
Yes, sir. Yes, sir. Next
So
phase
in the
we have
demo, you are going to connect all the Python scripts to menu-driven system, right? Using PHP programs.
yes, sir. Yes.
Okay, okay. Now, for this design development, how many days it took as a newcomer for
Sir.
this activities? You are new for ML understanding, right?
Okay.
Brand new.
Okay.
Okay.
Hmm.
So how many days it took from the day one to date today to understand and keep working in the back end, coming back into this kind of presentation? The effort I'm saying, asking.
Yes, sir. Yes. So initially, I started with understanding the data, what kind of data we need to use. So because initially it got like headache to understand everything. So I stuck so many times to understand the process designing and development of the ML model. So step by step, day by day. So I'm familiar with all these activities. So now I'm very comfortable to understand and explain what are the activities involved in any ML model to any person.
You have designed your own test data everywhere, right?
Yes, sir. Yes, yes.
You said you using GPT, you got the data means is it like directly you got the data from GPT, or you have created your Python scripts to create the test data,
Yes, yes. We have taken Python script. So that script will create a data.
test data?
Yes, sir. Yes. That script.
Okay,
We will
okay,
see
okay,
all the scripts in technical.
right. So let us see for your developed product, real product, shortly. Okay, good solution demo as a first timer.
Yes,